Okay, in this video I'm going to go over some more of the geometric mean problems. So look at the picture I have here on the slide. If I want to figure out what x is, I'm going to set two fractions equal. I'm going to put the x in the geometric mean position because x is the geometric mean of 5 times 15. Okay, so can you see where I got the 5 and the 15 from? Okay, so let's find out what x is. So we're going to do our products. So 5 times 15, that is what, 75, equals x squared. So I don't want x squared, I want x. And isn't 75 3 times 25? And isn't 25 5 times 5? So it looks to me, so I can take a double out, that x therefore would equal 5 root 5. Okay, let's go on to the next slide. Notice I have the same picture, and now we're going to try to find z. So put your z's, because all the red are geometric means, put them in the geometric mean spot, which is here and here. Now, the leg is the geometric mean between the side of the hypotenuse closest to the leg, so that's going to be right here, and the entire leg, which is going to be 15 plus 5, which is 20. So to get that, I had to add, I had to, let me get back out of there. I had to add these two numbers together. That's where the 20 is going to come from. Okay, so this is a 20. Okay, 5 times 20 is 100 equals z squared. So taking the square root of both sides, z is going to equal 10. Okay, we're going to do the y on the next slide. Okay, so same picture, but now the y is a geometric mean. So put the geometric mean in the geometric mean spot, and this time y is a geometric mean between the side of the hypotenuse closest to the y, which is 15, and the entire hypotenuse, which is 20. So 15 times 20 is what? So I'm going to take out my little calculator. So 15 times 20 is 300. So 300 equals y squared. So y will equal radical 300. But that is 3 times 10 times 10. There's our double. So 10 root 3 is what y equals. Okay, let's go on to another slide. Okay, so here's another problem. We're still looking to work with geometric means. So what do I have? Well, I know that the altitude, which is the y, is the geometric mean between the legs of the hypotenuse. So that's how I set that up. 6 times 24, that is 144, equals y squared. Y equals 12. Okay, let's go on to the next slide. Same picture, but now I want to find the legs of the original triangle. So what I'm going to do is I'm going to set it up so that I have my legs of the triangle as the geometric means, and they are the geometric mean between the piece of the hypotenuse that's closest to that leg and the entire hypotenuse. So notice I had to add 6 plus 24. So that's x squared equals 180. So x will equal radical 180. So we're going to work this out. So radical 180 can be, let's see, it could be 18 times 10, and 18 can be 6 times 3 times 5 times 2. And then 6 can be 2 times 3 times the original 3 times a 5 times a 2. Okay, let's get our pairs. So here's a pair. 2 comes out as a single. Here's a pair. 3 comes out as a single. And 5 is left inside the radical. So my x value is 6 root 5. Okay, we've got one more to do. So let's go to the next slide. Okay, so on this slide, I'm looking for the z. So set up your fractions, put the z in the geometric mean spot. That leg of the triangle is a geometric mean between the side of the hypotenuse closest to that leg and the entire hypotenuse. Okay, so 30 times 24 is 720. Okay, so z squared is 720. Let's work on this to figure out what z is. So that's going to be 9 times 80, which is 3 times 3 times 10 times 8, which is 3 times 3 times 5 times 2 times 2 times 2 times 2. Okay, check my math. Okay, underline your pairs. Each pair comes out as a single. So I have 3 times 2 times 2, and the 5 is left in the radical. So 3 times 2 is 6. 6 times 2 is 12. And 12 root 5, or radical 5, is equal to z. Okay, so that was 6 little problems we did. If you have to look at this again, please do so. I need you to get a good handle on geometric mean.